Hello and welcome. In this video, we'll examine standard GCO.9, in which students are expected to be able to prove 4 different theorems about lines and angles, the first of which is the idea that vertical angles are congruent. Many approaches are possible in proving this theorem. In this video, we'll concentrate on doing the proof by calculation. All right, and in particular, we'll show that alpha and beta must have equal measure. All right, so let's get started. First thing we're going to do is go ahead and rotate the first line from D onto A, and let's use the label alpha to represent that amount of rotation, so that'll be the measure of that angle right there. Next, we'll continue to rotate A until it maps to B, and in doing that, we've taken this line right here and we've just mapped it onto itself by a half rotation. We'll use the symbol beta to represent the amount of rotation between those two lines. All right, so what inference can we make on this basis? Well, let's have a look. So seeing that alpha and beta do form a straight angle, they're linear angles, we can write the equation. All right, so alpha and beta are linear angles, and therefore together alpha and beta must equal 180 degrees. The amount of rotation in a half rotation, or the number of degrees in a straight angle, however you like to think about that. Okay, second thing, let's get another relation going here. Let's continue to rotate those lines, but this time we're going to rotate this line onto itself. All right, so again, we've called that amount of rotation beta, and then we'll keep that rotation going till the line is mapped back to itself, and we'll call that amount of rotation gamma. So what kind of relation can we get, and what inference can we make about beta and gamma? Let's have a look. Well, this is going to feel very familiar because once again we have a pair of linear angles. This time, however, our focus has shifted to angles beta and gamma. So I'll write beta and gamma are again forming a straight angle. They're a pair of linear angles. And so once again, together they must make 180 degrees. This is a straight angle, this is a half rotation. Everything's looking like 180 in this picture. All right, very well. So now we have these two individual relations telling us how alpha and beta are related, how beta and gamma are related. Ultimately, though, to prove the vertical angles theorem, we would like to be able to show how alpha and gamma are related. Okay, and in order to do that, we're going to need to link these two equations together. So let's see what we can learn. Well, the first thing, and I had advertised this as a proof by calculation, the first thing is just to notice that if we know what beta is, we can actually figure out what alpha is. For instance, if beta is 150, then alpha would be 130. If beta were 160, then alpha would have to be 20 to make 180. So in general, we can take whatever beta is and subtract it from 180 to get alpha. Alpha must be the difference between 180 and beta. And it looks like we can say exactly the same thing up here in terms of how gamma is related to beta. If beta is 150, then gamma is 130, etc. And again, we can figure out what gamma is by subtracting beta from 180. All right, now as we look at these two statements, we can see that alpha can be described as the difference between beta and 180. Gamma can also be described as the difference between 180 and beta. And so we conclude, since alpha and gamma are equal to the same expression, they must be equal to each other. And that was what we were seeking to prove with the vertical angles theorem. All right, so we've shown that gamma is equal to alpha, both being supplementary to beta. That was how we did the proof. And then we make the inference that if two angles are equal in terms of their measures, then they're also congruent in the sense that a rigid motion would take one onto the other. Okay, and the conclusion is that any pair of vertical angles must be congruent. In other words, this argument works for any old pair of vertical angles, and so the conclusion applies across the board. Hope this video has been helpful. Thanks for watching.